remember the fade in your eyes. I'm lost in space, floating away. Away. I'm running away from you. I'm running away. I'm running away with you. I'm running away. I'm running away from you. I'm running away. I'm running away with you. I'm running away. Look at the stars, they find me. You shine so bright, it haunts me. I'm lost in this thick black sea of hopes for you and me. In the night I see you walking my way, sailing on my soul, your light. Come find me. I'm reaching.
Is he? As CEO, he brought in foreign workers for high-paying jobs that should have gone to Americans. When
They tell me that I'm never gonna make it. They want me to do something that could make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. I got all this potential that's deep inside of me, but they hate when you're successful cause they try to be. They sit there being judgmental because you're trying things, and they just want you to settle and do the right thing. So get a good job, don't slack off. Wake up every morning, make a good impression on your boss. Don't do anything that I wouldn't do, and when you're making money, make sure you don't spend it too soon. Fuck that, I'll do what I wanna do. I got a different path from everyone and that includes you. Who are you to tell me how to live life? In these times it feels like nobody's right, yeah. So I'ma figure out what else we succeed, and then invest all of my time into that and proceed. I need whatever the hell could make me happy, and I don't think you have a clue what could that be. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. I think this life could be special if I get rid of the devils. They think that I am a rebel, I think they want me to settle. There's nobody on my level. They think that work is too stressful, I think that work is essential. The grind is all in your mental, and I don't think you understand what I'll go through just to be in control of my life soon. All the negativity, man, I'm immune. I don't really need a mask with all I've been through. I've been making changes for the ages. 5-10 year plans are contagious. I attack that shit, I'm tenacious. And if you ain't, get the fuck out of my way then. Got one life, I won't regret it. I will fight until I get it. I'll look back one day from heaven and say, damn, I learned some lessons. And say, damn, I had no questions. I had fun in every second, and the journey was a blessing, yeah. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a who I am. I'm making a new plan, rearranging my life, and I won't look back ever again. You ain't see me activated. You better hope that you never see me agitated. I think about my actions, plan them out, evaluated. That's how I end up on the top, man, I'm calculated. My mind's a weapon, my body is the engine. I'm never second guessing, I just do what I was destined. Cause I feel I got the blessing, persistence and obsession. That's how you keep progressing, I already learned that lesson, yeah. I'm changing who I am. I'm making a new plan, rearranging my life, and I won't look back ever again. You can't stop what's moving. You can't stop what's moving. I'm changing my life, and I won't look back ever again. No fear, see clear, you deserve to be great. I know it feels like things get in your way. Push through those walls and the others will fall. Sit up, stand tall, you can get through it all. I need some energy, anxiety's no friend to me. I have a short memory, I don't really remember things. That's how I move on, that's how I stay strong. A new day's on, I'll keep moving right along. And I feel like the pain in the past, it needs to stay in the past. You gotta take off the cast. I wanna feel like I'm a new person. I wanna have clear vision and purpose. And I feel like the pain shouldn't last. If you can move on and past the things that make you feel bad, and you can change in your brain, I'm certain. I've done it before, and man, I'm not perfect. I'm changing who I am. I'm making a new plan, rearranging my life, and I won't look back ever again. You can't stop what's moving. You can't stop what's moving. I'm changing my life, and I won't look back ever again. I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign. I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign.
I wanna be the greatest. Everybody on the fake shit. I look around and feel like everybody is the fakest. I make this every day and I'm impatient, hoping one day I blow up from the basement. Statement, the top is so vacant. I don't hear shit that I think is amazing. Waiting for my day when I'm playing sold out shows for 1,000 faces. Hey, give me that crown, get in my way and to be put down. It ain't your place, all this my town. If I want that shit, then I'll get it right now. I'm losing it, the noose it fits. I'm losing shit, a stupid myth. You choose to live or choose to dip. You choose to fight or lose your grip and lose a gift.
I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign. I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign.
Yeah. There's no mercy in this world, just hunger-thirsty persons in different versions. Each new update, that shit worsens. Why? Pull back the curtain and you'll see the different vermin. We all have different burdens that all seem to cause disturbance. Yo, so do me a favor, don't treat me like a neighbor. Don't need the different flavors of your problems just to savor. I've got my own issues, I need a comb to get through. Don't need to groan with you, just go get your own tissue.
I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign. I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign, a sign.
That's that's it, the end of the song. Next time you'll sing along. Trust me, there's nothing wrong, I just need to carry on. Cause society's a myth, put there to make you sit. Listen to what they give, don't ask questions, shut your lid. Yeah, don't ask questions, shut your lid. I need to run away from this and go get off the grid. Feel like my brain is overloaded, man, I'm losing it. Don't let them tell you what to do, man, they don't know shit.
Well, I heard my name. You heard Vincent open the door? Yeah. That's crazy work. Hey, hey, Rich. Crack. Yeah, please.
You're fixing to go to sleep and I'm fixing to throw something. Banana? Like a bright field out here.
Come on now. What happened? What happened? Yes, it's on. Yeah. No frickin' camera. That can be nice. Okay, let me go over here. Yeah. That should be one. I'll put that one somewhere. Yeah. Honestly, I think it's yes. Tell me. Oh my God. I'm not into Nutella. Let's just go over here and copy that. It's good enough. Window capture. I'm press wait in a minute. Try something like this. There's not going to be any. I would. Let's try this some more. Okay. Try it. I can do this. Almost held. Ow. Ow. Okay, well.
Yo, good luck syncing. This up, whoever's editing this video. Hopefully not me.
The DVS 510, the DVS 510 again, the ATEM, the streaming computer, and then this one I chucked, but I'm not actually using it, my stream server, because I have the most ridiculous setup ever. Don't worry about that. Now, the DVS 510, quick. Talk about this because I discovered a weird bug with the DVS 510 right before I started recording this today, and I had to use a workaround for this. Now, the DVS 510 can work. This is really not easy to explain because The software may not do as much as you think it does because video hardware can be far too different. Everything you see here is actually generated from a single JSON file that is used to define your connections to your hardware, as well as the different interfaces that you want to have show up over here and what those buttons do. Now, I am not using all of the features that this software has here because I don't need them all for this, but this can do more than you can see here. And if you want to have an idea of what all it can do, you can go to GitHub, and I will link this down below because you can look at a lot of documentation that I've written for this so that you can understand how to use it, because it is so ridiculously complicated. Let me walk you through how this actually works, because it is not trivial to set up. And again, there's not a lot I can do about that. So first, this software has a concept of video controllers and sources. That is how I am differentiating the devices that you work with and the actions that you want to send. So here I have video controllers for the IN1606, the MPX866, the DVS510, the DVS510 again, the ATEM, the streaming computer, and then this one I chucked in there, but I'm not actually using it, my stream server, because I have the most ridiculous setup ever. Don't worry about that. Now, the DVS510, let me quickly talk about this, because I discovered a weird bug with the DVS510 right before I started recording this today, and I had to use a workaround for this. Now, the DVS510 can work over Telnet or use an HTTP API. Now, if we go to the DVS510 manual, I can search for CMD equals here, and we can see that this is how you send this hardware commands over HTTP, but it also supports Telnet. Up until now, I've been using this only with HTTP, but I found out today, as I was trying to do some more complicated stuff, that when you send it commands that need escape sequences, you can't actually put that in a URL. So I had to switch to using Telnet for it. But then when you connect to it over Telnet and you try to send it the same input that it is already on, it locks up for some weird reason. So using the HTTP interface to switch inputs and then the Telnet interface for everything else seems to be reliable. Now, you might think that that would be kind of a nightmare to implement, but that probably took me 2 minutes to fix, which is one of the areas where this software is really powerful, but to be able to know how to do that is where this becomes kind of a nightmare. So if you notice over on this side, we have lots of indentations and cascading areas, and that's because of how this works. So these are the video controllers, and then down here are the sources. Each source starts out as a dictionary entry in the JSON file. And you can see here we have location and then filming location. Up at the top, I have 3 filming locations set. When I click one of these, like let's say Workbench, it reconfigures all of the video inputs, hello, for that location. You'll notice it has removed the little preview window up there, and we only have that camera. Now, if I go back to Workstation, it switched to the capture input on the ATEM, and then it's brought up this view here, which is actually a USB webcam that's connected to the streaming computer down here. Then the desk starts out by showing just my phone with a wide view there, and then I can click one of the computers in particular to drill down into, because I figure if I'm walking over there, I might want it to start off with that. And then we can hide some of that ugly video switching, but not all of it. Now, let's go back to Workstation. Anyway, so we have these 3 big buttons up here, and you can see that they kind of do a lot of things. For Workbench, we can define the name that shows up for the button over here. And here's one of the cool things that I have done with this software. I can change the name here. So Workbench Demo live change. All right, all I'm gonna do is save the file and then refresh the page, and this is now changed. Every time you refresh the page, it reloads your configuration file, which is super handy when you're configuring things live, but can also bite you if you mess up the Java formatting, because Java is, or not Java, JSON. JSON is really strict about making errors and weird things. It's kind of annoying. If you're not a programmer, I don't know if this is really going to be the software for you, but if you are a programmer, you might see the brilliance in this. I don't know. So that's one of the things that we can do. We can also do something like change the background color here. So you'll notice that the VGA area is slightly blue. What I can do is I can change the background color to, let's just go with red. All right. And then I'm going to add a comma there. What did I mess up? Is that a semicolon? Yeah, it was. Okay, so make that red, and then we're gonna make the text color just white. These are HTML commands, by the way, so we do that, we refresh, and bam, there we go. So we can directly set the foreground and background colors in this, which is pretty handy. So that just gives you an idea of how this works with the configuration options here. Now, every video controller up here has a key defined in this, and you can use that key as another key down here to say, I want to run these commands on this controller. You assign these to the different sources in here, and that is how the actions are tied to that. Every single source can have a key for every single video controller. Now these ones up top are really complicated, so let's go down to the ones for the VGA resolution options, because these are much simpler by comparison. So the first resolution option we have down here is auto image. And for that, we just connect to the DVS510 and we send it to the command 2*A. Now, I can't wrap every single command for every single video controller because they are too weird and too complicated, and the software would just become a database essentially of generic command descriptions and hardware specific command entries. And the only thing you need to do to know what these commands are is just go look at the manual. So I would recommend that you look at the manuals for any hardware you have, because you're going to need to know what these commands are. Now, I've tried to help somewhat with this, and I'm working on explanations of how to use some devices. So for the Extron, for example here, I have written I think my internet just died. So for example, the Extron controller here, you can go through and you can see how you can initialize a controller. I think my internet just died. So for example, the Extron controller here, you can go through and you can see how you can initialize a controller. It tells you how the interface works for this. And then I've given a number of command examples down here, which includes the auto image commands. Although these can be different for different machines, so this one is correct, but I think some of them might require a backslash after the A. Or is that for loading a preset? I don't remember. Anyway, you'll need to know the commands because I can't have them all pre-programmed. So anyway, this is an Extron specific command, but you can just put it in here. Now, commands are stored as a list so that you can have multiple commands in here, which is how these commands work. These are the commands that set up the horizontal position, the vertical position, the horizontal size, and the vertical size. These commands here. Now, these commands are just a list of the different commands that you can send this, and these are executed one at a time. Now, up at the top, we actually have the option to define a command delay. So if your hardware needs a moment to process these commands, you can have this command delay, and it will wait that amount of seconds between sending the next command. So in this case, the DVS510 for normal commands here, I have waiting 50 milliseconds between commands. For the input switch, I'm having it wait 1 whole second. That way, I know that it's had time to get itself sorted out. So for each one of these resolution commands down here, we are sending the DVS510 4 different settings so that we can configure how it works. Okay, that one's easy enough. let's go look at a slightly more advanced one for the ATEM inputs here. So under main source, I have the ability to just directly select the different ATEM inputs. And the reason I did this is because I don't want to have like Workbench arm or Workbench face. I want to be able to directly switch between these, but I do want them to make some considerations. So when I'm at the Workbench, let's go ahead and select that right now. When I switch to the arm camera, I want it to show this little view up here. You know, this one that my arms are wiggling in. So it needs to do multiple things at once. But the ATEM is really complicated. So the ATEM, I have, let me bring up my, no, this is a controller. Oh, this is slow. Oh no. Now the ATEM is very difficult to work with, and that's because I would classify the types of controllers I support here into two types: generic interfaces and dedicated interfaces. Now, the generic interfaces are the ones that use serial, telnet, or HTTP. The dedicated ones have specific Python modules that I import in order to work with. Now, in this case, we are using PyATEM Max to control the ATEM. And this has a bunch of functions or class members that you call to be able to do all of the different actions you want on the ATEM. You can't put function calls in a JSON file. So what I have done is a very complicated thing where you can define a dictionary entry, put the function name as a key, and then a list for the parameters. And now we'll finally look at the Python code, which is long-ish, not super complicated, but the way that this works, if we go to the ATEM part here, we check if the switcher class from the PyATEM software has the function that has been passed in the JSON, and then if it does, we pull that function out of the object and call it with the parameters that were passed. So this lets you directly call Python functions from the JSON data, which took a bit of work to figure out exactly how I wanted, mostly when it comes to OBS, because OBS is on a whole other level of pain. Now, if you do happen to have an ATEM, you'll notice that I have a lot of just weird magic numbers in here, and that's because this library, which works fairly well, it doesn't work perfectly. I haven't got any of the audio options to work in this, but the video stuff all seems to be working well. Anyway, this software has a bunch of like hard-coded enums in here, and if you don't know what that means and don't have an ATEM, just let it go in one ear and out the other. But you're gonna have to look up what the data objects are in this and see what they are hard-coded to. I would recommend importing the class in a Python. The object names for the enums in here. There's no way I could figure out how to do that without it being insane. So we directly call the Python functions by using for the commands. And that's how we do just the face cam. So we set the input source to input 1, and then we disable the little tiny view where, you know, I am with the webcam here, right there. Where this gets a lot more complicated is OBS. So OBS has a WebSocket API that allows you to send commands to OBS over the network. You have to enable the WebSocket interface and then get the password and everything to log in. But it works fairly well, although it has been kind of crashing every now and then on me. Change something, but let's just chalk that up to the computer that I'm using not being amazing for it. Now, where OBS starts to break down is how it works with different kinds of data types. So if you want to change a scene in OBS, it's trivial. You set current program scene to the name of the scene, and that's fine. But let's say you want to hide a source. Like, let's say you have a phone that is remotely broadcasting data and you want to be able to show that or not. Well, welcome to my nightmare, because you can't just tell it the name of the item in the scene. Oh no, you have to get a scene ID. So the way that this works is in OBS specifically, I don't know if the ATEM needs this. I don't think it does. So I haven't implemented that. But OBS has the ability to chain nested functions using this whole ridiculous thing. But long story short, to get the ID for the item that you want to enable or disable, like my phone camera, first you pass a function that gets the ID, then it returns that as a value that you can use as a parameter, and then you can call the actual item enable or disable function. So this layout here is actually the same as this, but let's say this 0 here, we needed to query from the ATEM. We can replace this with another function call, and the return value of that function call is just passed on as if that was what was typed there. So here we want to change the scene item phone, but we have to get the item ID from the scene that it's in, and then we can pass that on. It's ridiculous. OBS's software is really difficult to work with, but I would say that's only because OBS itself is very complicated. You can do some ridiculous stuff with OBS, so I don't really know how else they could have worked with this, but that's what it is. So the other thing I will mention here is that this scene item ID is an optional thing you could do. We could eliminate this part here, and this will still work just fine, because the output from this function call, which is using the OBS Python WebSocket wrapper module here, when you call the get scene item ID function, it actually passes an object that has the scene item ID attribute, which then contains the ID. It doesn't just pass a number directly back. So if you use a dictionary and then put the key of the parameter that you want to pull out of the returned object in there, and then put the value of that dictionary as your function call, you can then specify exactly what parameter you want to pull out of the returned object. Again, it's ridiculously complicated, but there was no other way that I could do this without hard coding everything. That would be impossible to dynamically set anything up. So OBS is absolutely ridiculous for how you implement it, but it is possible to do some complicated things. So what else do we have here so that I can show you what nightmares are lurking? Well, you can chain commands. So here we are enabling or disabling the webcam overlay, which is what you're currently viewing me through. If we go to the desk scene, because it needs to be able to show the phone camera instead. And we also disable the phone overlay. So there's actually 2 phone cameras that are enabled. If I go over to OBS and I manually enable the source item and enable that, and there we go. That is the kind of cursed thing that I'm trying to avoid having show up, because we can see both phone cameras at once, which is not desirable. So I'm going to go ahead and apply the workstation config, which resets all of the settings back to exactly what I want. Those kinds of complicated setups are where this software shines, because we can enable or disable everything all in one go, and that's why we need to be able to have so many nested commands. Now, I think I've hopefully shown you enough so that you can understand how this works, at least partially, and why you need some of this stuff. Because let's say we want to switch to the Windows 98 PC here. If we go down to the Windows 98 PC sources, we have to select on the cross-point matrix the input to the output we want. We set the DVS510 to the input that it uses for the matrix. DVS510 then again, after we connect over Telnet, to auto image so that it correctly phases and gains and all that. Desirable. So I'm going to go ahead and apply the workstation config, which resets all of the settings back to exactly what I want. Those kinds of complicated setups are where this software shines, because we can enable or disable everything all in one go. And that's why we need to be able to have so many nested commands. Now, I think I've hopefully shown you enough so that you can understand how this works, at least partially, and why you need some of this stuff. Because let's say we want to switch to the Windows 98 PC here. If we go down to the Windows 98 PC sources, we have to select on the cross-point matrix the input to the output we want. We set the DVS510 to the input that it uses for the matrix. We set the DVS510 then again, after we connect over Telnet, to auto image so that it correctly phases and gains and all that stuff. Because if you turn on the computer and maybe I use the KVM to switch to a different computer, the image will be distorted if it's not correctly auto aligned. So we need to call that. Then we set the IN1606 to have the correct input there. We set the Stream PC up with the phone overlay in the upper corner. And then we disabled the big phone overlay that was probably enabled when we got there. Now, one thing I could do at this point also is disable the webcam, but ideally what I do is I go desk and then this, but I could end up going just to this, which might mess things up. But I do want to limit some of what I put in here, but there's not a lot of choices for it every time. Okay, so we set up the PC, and then finally we switch the ATEM to the third input, which is where the IN1606 is connected. We set the keyer source to the face camera input, the one that you can see when I'm working at the workbench. Actually, we could disable this. We could get rid of that, because the next line we do is we disable that entirely. I probably set this so that if I go back to the workbench, it doesn't have to reload that. It is one of those things where you can make a change in the background to like preload for something else. So anyway, we have to do so many different things here that it is kind of ridiculous. But with all of that, it's still not perfect, because there is one thing that we can't do, and it has to do with how you can see the ugliness of the video switching happening. So if I go workbench, and then I go desk, and then I go Windows XP PC, you will probably see it do some final switching to the Windows XP PC where the video, yep, there we go. It flashed one thing on the ATEM. We have random black, and actually it's going to stay black because the PC is like putting itself to sleep. But that doesn't, you saw it do some weird switching. Now, the IN1606 has an option to fade to black, and we can also do a video mute or not. It would be really cool to be able to fade to black, and you can do this on the ATEM as well. Fade to black, do the switch in the background while the video is not being sent out, and then fade back to the video and display it after you do all your switching stuff. The one thing I have not implemented in this is the ability to call the same video controller twice in one action, which is kind of a hack job that I did here, which you could do to work around this. So let's say I wanted the ATEM to fade out. I don't know what the fade button is here, and I don't really want to look it up right now because it's always a pain in the butt to add an ATEM command. But let's say I wanted to add an ATEM fade up top first. What I would have to do is I'd have to go up here. I would have to copy this. I would call this, say, ATEM 1, ATEM 2. They can point to the exact same device. This just gives you two keys to reference this device by. And then we could go through and I could have ATEM 2 down here that fades in the video. And then up top, I could have ATEM 1 that fades out the video. Kind of an annoying, dumb setup, but it beats the alternative where the command set inputs get way more complicated, because I would have to put each of these into a list then that each have an order assigned to them, and then it would just be so much worse. Trust me, you wouldn't want that. So dumb workaround is the better solution. All right. I think that might be everything. If you want, you can look through the code itself. I've tried to document it as best as I can, way more than usual actually, because the whole thing with the video stuff is that it is such a pain in the butt to keep maintained and utilized. So that's why I needed to write this software to simplify this. So I know that this is also some incredibly complicated software. Like one example here, okay, this is one of those things where I'm just trying to plan ahead. So let's say you, the viewer watching this, only have an Extron device and you want to use this software to control that. Okay, what you can do is import the software or download it, clone it from GitHub, and then set it up for, say, Telnet. When you go to run it the first time, you have your Extron IN1606 Telnet config, let's say. The first time you run it, it will try and import the Python Telnet module. It won't find it if you don't have it installed, and then it will tell you that it needs to install it. But it will not try to import the ATEM module because you don't have an ATEM configured. So this way, you don't have to have every single module installed that this supports unless you're actually using it. So that's one of the things where I've tried to think ahead for this. Let's see. Oh, I guess I haven't covered how the layout actually works. This is something that is covered in the documentation here, but you can nest sources in the layout. So let's look back at the config here. So first, we have the primary sources entry here. This is the top level, okay? We have the filming location, which is rendered here. Then I have a second sources entry here. Now, when you put a source list in a source item, it will render it as an HTML field set like this, and put any name that you may have here up here as a legend. Now, the reason that the legend is important is, let's say you want to be able to hide this. Well, now you can just click the legend and that goes away. I actually have this set up so that when I first reload the page, the VGA capture area is hidden. That way I can't accidentally hit any of that, which is a nice thing to be able to block out if I want. So I can click this, bring this all back. Maybe I have set the PC that I want to set and I don't want to be able to change it. I can just leave it like that, or maybe I'm happy with the resolution and I want to be able to hide that. Features that just kind of naturally came out of this. But if you nest sources like this, it will match the layout over here, and you can nest these indefinitely. So here is a group inside of a group, so that I can have the main sources split between sources on the PC, my phone, and the ATEM. So source grouping is like that. Now, we can see here that the VGA sources are bigger. If we go down to that area here, we can see the name is set there, but then I have a description set here. Now on the home page for this, I show what descriptions look like when you implement them. But the thing is if you add a description, even if it's blank, it will change the rendering mode for that source item from a small button to a list item that fills the width of the page. This is useful for organizing the buttons, how you want them to be displayed. And I feel like that's a good way to go if you have like a couple of really big things that you want to be able to make like obvious. The other reason I do this is so that if you are adding icons to this, which you can do, you can make the icon items be wide or, have different options for how they're laid out. Because if you have different sized icons, you can end up with some like weird stuff with how things are laid out, but that helps make everything the same. So you can see down here for the VGA resolutions options, actually, the widths are all completely different, and you could, make them all identical by just having them go full width. But the downside to that is there's kind of a lot of options here that I'm going to be implementing, and I don't want to have like this be like a giant long page I have to scroll through, especially when I'm able to use this from my phone because it's a web page. On that, I didn't mention that. Launching the software, now I can kill this right here and this isn't a problem. When you go to launch the software, you can run the built-in help and it tells you everything that you need for setting this up. Oh, this does have a really cool feature. So if we do -S, you can see for the serial devices that are here, we have name as Greaseweasel, and then we have by ID and path, which is this whole ridiculous nonsense. If you have a serial device, like say the RetroTank 4K or For me, I have to use my Extron Crosspoint RGB300 over serial. And you have maybe the same serial device multiple times plugged in, like you ordered a bunch of the exact same one or something. You can use these values here instead of the dev TTY USB 0 or whatever as your way of connecting to these. I use a setup here where every serial port that's called checks against a Python serial object list, and then we'll get the dev TTY USB whatever thing by matching to this. So this makes it much easier to easily define serial devices like this, particularly USB serial devices, because when you go and plug these stupid things in, there's a chance that the USB paths will be different, and you can have them swap around in numbers and stuff and IDs. So they're kind of a pain in the butt to use when you have multiple of them connected. So being able to pick out something, especially something that has a specific name set like this, is really nice. But anyway, you can also set the interface that you're listening on. I guess I forgot to update the text for the port, but you can change the port. By default, it loads to port 5000. And then you have to pass the configuration file. Oh, this is one thing. You can set commands for the hardware that are called on the initial load. So I think I have the sources here. Yes. So, or no, controllers. That's what I want. Video controllers. Okay. So you can have a command init option set. So for your controller up here, we could add cmd underscore init. And let's say we always wanted the IN1606 to be on input 5 when it's first started. We could add that right here. And then every single time the IN1606 is first started or connected to by the software, it will connect that way. I have a bad Extron device. I may have mentioned this already, but the flash is bad and it's stuck in executive mode, my Crosspoint 300. So what I actually do is I have an init command on my configuration at home where it resets it to factory defaults on startup every single time. And then that allows me to reconfigure the device over serial. So that is one useful thing, but there is an option if you don't want to reinitialize the hardware with the command inits. So, I think that might be everything for this. So we can go ahead and go back to the workbench. Well, that is my software for controlling different kinds of video routing devices and how it can be used and implemented. It's not easy, I know, but it's the best that I could do given the variety of different kinds of interfaces and commands and just all of the things that are involved here. I tried to look up if something like this already existed, and I couldn't find something as flexible as this. There might be a few programs out there that can individually control these kinds of devices, but I couldn't find anything that really tries to bring them all together, which was the goal here. Sequenced commands for multiple devices to impact a big output, and I'm really happy with how this turned out. Well, if it sounds useful to you, it will be linked down below and you can find it. I guess I should mention here that this is a computer run program kind of meant for video capture. You can kind of think of this video as a prelude to the video capture series, really. It's never going to have an iOS or Android app version. That's just not something that will happen. Trust me, you don't want to try and write that JSON file because you have to manually write it on a phone. That would be terrible. So you're going to want a computer no matter what, and it's going to need to be run on there. It's written in Python. It uses Flask as the web server, but yeah, I think those are all the big points. If you found this video helpful, you may and not something that will happen. Trust me, you don't want to try and write that JSON file because you have to manually write it on a phone. That would be terrible. So you're going to want a computer no matter what, and it's going to need to be run on there. It's written in Python. It uses Flask as the web server, but yeah, I think those are all the big points. If you found this video helpful, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. This was the first video I ever recorded with OBS. It feels kind of weird because now I'm just going to tap stop recording over here to end it. Feels kind of weird because now I'm just going to tap stop. But for now, that's it, and I will see you next time. This was the first video I ever recorded with OBS. It feels kind of weird because now I'm just going to tap stop recording over here to end it. 866, the DVS 510. The DVS 510 again, the ATEM, the streaming computer, and then this one I chucked in there, but I'm not actually using it. My stream server, because I have the most ridiculous setup ever. Don't worry about that. Now, the DVS 510, let me quickly talk about this because I discovered a weird bug with the DVS 510 right before I started recording this today, and I had to use a workaround for this. Now, the DVS 510 can work over Telnet or use an HTTP API. Now, if we go to the DVS 510 manual, I'm always looking for new and better methods for my archiving workflows, and one area I've never expanded upon has been optical disk ripping. Up until now, I've just used the drives in my computers or USB drives, but I've always had my eye on disk changers. In 2017, I did a video on the NEC slot loading changer, and in 2022, I did a video on the Torsen caddy changer, but those were never the end goal, just a fun step along the way. Some things I haven't made videos on are these Pioneer DRM 6324X and 1804X jukebox changers. These take the 6 disc caddies from Pioneer's home stereo line and let you work with many more discs at once. But the reason I've never made a video about them is that they don't allow full access to the discs and are completely unsuitable for ripping. But I have known what the real answer was for years. Disc duplicators. A whole product segment dedicated to high throughput CD and DVD work, though for writing, not reading. I managed to find an example of the most common variety of these locally, but that's just the tip of the iceberg. The next style is one of these, a hopper-based solution that can drop discs down from above. But even that can be bested. This is a 3-drive, 3-hopper, robotic disc duplicator, capable of queuing up to 200 discs and working with 3 of them at a time. This is my dream machine for disc ripping, but it had many problems. There was no documentation on how to use this thing, and the CD drives in it failed one of my tests to be suitable for archival ripping. So I had to completely reverse engineer the software interface and modify the unit with new drives. Sounds easy, right? Well, this took about a month of non-stop work, so buckle up while I walk you through why you should never get one of these, but why it's so awesome and you'll want one anyway. First, let's go over what these actually are. This is an Alaritech RoboRacer LS, and this is the kind of changer you should want, except this one kinda sucks too. The other is an Alaritech Autopublisher LS, and for completeness, this first one is a generic copier, but what piqued my interest, aside from the Plextor drives, is its claim to do CD plus G, something I will test in a future video. But both of these machines were also available as an SA model. The difference is that the LS units are controlled by software over USB, and SA units are standalone. Keep in mind, these are meant to act as duplicators. They're advertised as being able to write discs for low to medium volume publishing, so it'd be an advantage for the standalone models to be able to write discs without a computer, but they also typically weren't meant to connect to both of these units at once. But frankly, if I'd only bought the RoboRacer before the Autopublisher,
I would be happy. Its hopper holds up to 50 discs and uses a simple sliding tab to push one disc through at a time. The discs fall down a set of rails and land into the drive tray. Then you just close the tray normally and work on the disc. Ejecting is where this one gets weird though. There is an arm underneath of the tray that can move up and down. This arm actually holds the tray up, and when it lowers, you'll see the tray is hinged and the disc is able to fall to the side and land in a bin. This makes the tray in this drive unique because it must have that hinge in order to work. This would be fine, except the Lite-On drive in this fails my first test for being archive capable too, but we'll get to that later with the other machine. For now, I haven't covered how you actually use this. The unit has a USB IDE adapter to connect to the drive and a USB serial adapter for the interface. They are connected internally through a hub chip with a single USB port for both. Connecting it to a computer has it show up as a normal disk drive and a serial port. The machine accepts commands over serial to perform the different actions it can do. Thankfully, this machine has already been documented online and all of the commands I needed were available right here. Really, there are just 3 commands you need. Kick down the next disk, arm up, and arm down. With just those, you can do everything you need. And I've been working on the perfect solution for integrating these kinds of commands into my ripping workflow. I have been writing my own modular media archive tool to handle automated ripping and decoding of data from different sources. If you want to know more about this software, I've made a video going about it into more detail on my second channel. Since that video, I've been working on a web interface that allows you to queue up sources to rip and manages going through them. Now, integrating a disk changer into this was always one of my goals. I added a concept of controllers to my software to handle this. When a sample's load or eject action is called, if a controller is assigned, then it defers to that. This is where the changer's commands are sent for loading and unloading. Controllers are enabled in a settings file that you provide when you start the software and assigned to the drive set up. So all I have to do to use the RoboRacer now is to define its drive and associate its controller with it. Now I can load disks into the hopper and start queuing them up for ripping. It will automatically drop them in, close the tray, and start the rip. When it's done, the arm is lowered and it ejects the tray that will drop the disk into the bin. Now this is very definitely the abridged version of how I got this thing working, but the other changer proved to be so much more work that we're going to be talking a lot more about it. But I'll say that this machine is way easier to use and works super well. If it weren't for the drive, it would be the easiest recommendation for an automated ripping solution ever. Now there are similar models from other brands with a different loading mechanism that might work better, but I don't have those. So instead, it's time to talk about the big one. This is the Alaritech Auto Publisher LS. It uses an arm with a clamp to grab disks and deposit them into the trays of the 3 drives it has. Like the RoboRacer, this is meant to act as a duplicator. Now as an aside, I watch on their boxes because it's kind of a terrible way to label your disks for consumer use. They provided the driver disk for both of these units on LightScribe disks and they look expectedly meh. There were changer duplicators that integrated full color printers instead, which would look so much more professional. Speaking of the driver disks though, I didn't talk about the driver disk for the RoboRacer because they kinda screwed up and didn't put any software on the disk. It's just a PDF of the manual. The Auto Publisher's disk does come with the original software though, which is a really good thing because it is the only known copy of something that can interface with this machine. Or at least it was. Unlike the RoboRacer, there was no information online about the commands to control this machine. It works in the same way with USB IDE adapters and a USB serial interface on an internal hub. But this is only ever meant to be used with the original software though, which is Dropix Recorder XE. This is a program specifically for bulk disk writing and controlling robots like this. This is a somewhat limited version though that only comes with the driver for this Alaritech robot though. To use it, you have to set up the drives and then calibrate the robot. After this, you can run a test and see the robot perform a full load and unload cycle. and this is the most I've ever used this software. I'm not interested in writing disks, but I am interested in how it works. The driver turned out to be a single DLL that I was able to easily extract the strings from. There was a lot of garbage to sift through, but after working on the RoboRacer, these lines stood out to me as likely being commands because they followed a similar structure. This let me know what I would probably be looking out for as far as how to control the robot directly, but that wasn't that useful on its own without knowing what the commands do. Now, I'd put this DLL up on my Discord server as well, and some of my viewers there started trying to reverse engineer it more directly. They found some info in there related to the commands that gave us an idea what they do, but it was a little confusing and far from the complete picture. That wasn't the method I wanted to use, though. I've been running the original software in a VM on a modern computer for a reason. With this method, I could intercept the transmitted data from the host OS and see everything the original software does. To accomplish this, I'm using Wireshark on Ubuntu. After setting up USB redirecting, you can use LSUSB to see what bus a particular device is on. Then you can start monitoring that bus for USB traffic and look for data sent to or from that device. With that ready, I ran the robot test and was able to see the commands sent to the robot. These were the commands it sent to do that. Now, I took a bit of a safe guess that the 3 big motions that it does are related to the 3 larger commands. First, some kind of check on the drive, then it loads a disk, and finally, it unloads a disk. We can deduce a bit more from this, though. It unloads a disk from drive 1 to bin 3, and it loads a disk from bin 1 to drive 1. This tells us the packet structure has a command indicated by the C group, then 2 data groups behind D and N. The C1 and C2 commands as obvious though, but from the DLL we had a hint they could be something like cancel command, clear alarm, and home. This was the beginning of the process that I would be using for reverse engineering this thing, but that was far from making it work. The next problem was initializing the machine. When I went to try and send commands back to the robot to see what they did, it worked. The first day. The second day, it didn't work at all. I left out that when first connecting to the robot, I logged the software sending these commands, but they didn't seem to be working later. Now, around this time, I ended up changing from using Wireshark on the Linux side to Portmon inside the VM, which was easier to see the commands and responses. More importantly, though, it also showed me how the serial port was being configured by the software, which was kind of confusing. In the end, it wound up just being 9600 baud, 8 data bits, even parity, and 1 stop bit. And I'm getting ahead here, but DTR had to be held low when connecting over USB, but not when directly connecting over serial. After that, I reran the logging with the software and found it sent way more commands that time. I had theorized that the robot would store its calibration data and recall it with the original commands, but after seeing the wall of data it was sent, it was clear I was getting all of the calibration data from the software and was replying somehow that it was already calibrated on subsequent queries. The response to C8D9N2 specifically seemed to indicate the calibration state. I modified my work in progress software and was able to send it back all of the calibration data directly and was able to start controlling it from a cold start now. From there, I went to work on figuring out what all of the other commands do. I began documenting everything I found on my wiki, and there is now a very complete documentation of how to control it. This took a lot of work and trial and error to do. There are a lot of complex elements to this. Every command gives you a status response that indicates errors in machine state. This is useful for adding smarter logic, like my software will detect that no disk was found on a load command and will automatically try the next bin, which allows for adding more disks to the queue while it continues to work. This technically means that it can rip for an indefinite amount of time as well, but the RoboRacer can do the same thing in a much less complicated way. Now I'm not going to go over all of the commands and calibration properties because this thing is insane. There are other robots like this made by other companies, and from what I can see, they are all drastically less complicated. After all of this, I was actually able to take the logic for my robot and dumb it down to work with a generic command set that enabled my software to work with a disk robot that one of my supporters has. Thank you, Matrox Millennium, for trying this out and getting me some footage of it working. It is so cool to see this being useful for other people. But that machine has commands like I and A, so that took like 2 hours to implement. My machine is way over-engineered. For example, there are 2 unload commands. C4 is the normal one, and the other, C10, is identical, except when it raises the arm, it waits slightly longer before moving back down again. This is meant specifically for putting the disks on the reject spindle, which is down here, and technically bin 5. The delay is to give the drive trays time to close. My machine also allows you to fully control the arm, which allows for custom movements. But no, it doesn't let you drop a disc while moving, so you can't make a throw command. I was very disappointed. Now I've also figured out a lot of the calibration values, but that didn't matter too much yet. It mattered a lot more though once I changed the drives. Okay, so now let's go over the drives in both the RoboRacer and the Auto Publisher. These drives are made by Lite-On, and like I mentioned earlier, I rejected them for archival purposes. My main test for this right now is the album Factory Showroom by They Might Be Giants. This CD has a hidden track before track 1. On a normal CD player, you can access this by starting track 1 and then rewinding into negative time. This is easy for most CD players, but very difficult for a lot of CD-ROM drives. Most of them will refuse to read data outside of the regions in the table of contents. This includes these Lite-On drives. Attempting to read for track 1 will throw interface errors with the drive. So I don't want to use these, and that's why it's a shame that the RoboRacer's drive is unique. I use this particular test because if a drive can read that far out of the talk, it probably doesn't have too many limits and will be better off for reading more complicated CDs. This isn't the video to get into the complexities of CD ripping, but it's awful. Now, to make a long story short, I'm using ASUS DRW24B1ST drives, and they can read the hidden track. I owned 2 of these before this project and bought a third to complete this machine. This drive isn't on any of the compatibility lists for the big CD archiving projects yet, which is why I went with it. It's still affordable, and since I needed 3 identical drives, it wasn't financially crippling to get them. Also importantly, it is a CD and DVD drive, so I can throw almost anything in there and be just fine. I'm skipping Blu-ray, varies a lot more by play. It's usually not suited to bulk ripping like this anyway. So this is about the perfect setup. At least it is now. While these drives are technically fantastic, the implementation of them in this application was a complete nightmare. But before I can even get into that, there's a bigger problem to solve. You know how I mentioned that there are USB IDE adapters in these robots? Well, the ASUS drives are SATA. And inside the robot, we can find this very custom board that is very much only ever going to be IDE. I needed to make some changes, but I was okay with that. Switching to SATA was always my plan. Mostly though, because I also wanted to switch the internal hub to a USB 3.0 one to be certain that I was never going to run into bandwidth limits while ripping. Generally, while writing discs like this was made for, slower was better, so the speed of the disk access was never really an issue. But for reading, we can go a lot faster. These ASUS drives are capable of 48 times speed CD reading. That's 7.2 megabytes per second. All 3 running at once would be roughly 21 megabytes per second. USB 2.0 is theoretically 480 megabits per second or 60 megabytes per second. So that should be safe, right? Well, have you ever seen a USB 2.0 device hit those speeds? Because I sure haven't. And here's a great and simple QA page from Microchip on why. TLDR, you can expect to see about 35 megabytes per second max because of the packet structure and driver overhead. And we can kind of confirm this by looking at the Wireshark captures from the serial commands. The actual data of the USB packet is a small percentage of the total of what is sent. So that 21 megabytes per second for all 3 drives would most likely be constrained by the USB 2.0 bus, considering all of the overhead. And I probably should have just led with this, but if I'm ripping 3 DVDs, these drives can reach over 66 megabytes per second, exceeding even the theoretical speeds of USB 2.0. So going USB 3.0 and SATA just makes sense here. Now I could just build a pie into this with a PCIe SATA hat, but that really limits how this could be used. So I was determined to keep the USB connectivity while upgrading it. I decided on a very particular setup. I found a 4-port USB 3.0 hub that specifically had a female USB-C data connector on it, and also supported power injection, though power injection would be far more important than I knew. I was then going to use a USB-C panel connector to allow connecting to the hub with an external cable. So that solved the USB data. Now for SATA. I bought 3 of these USB 3.0 SATA adapters that were very low price, so I could install them in the back of the drive cage without having to worry about space. They also have external 12 volt, which I plan to tap from the ATX PSU in the Auto Publisher. So far, so good. Well, not quite. One of the USB adapters that I bought was DOA. That sucked, but I got a replacement on the way and used a different adapter that I already had on hand in the meantime. This was delay number 1 on this project. I wanted to be smart about this and decided to test everything outside of the robot first. And during that, I was having considerable trouble getting all of the drives to work consistently. I was working on this live and it was pointed out to me that SATA optical drives used a lot of 5-volt power. I figured it couldn't be that much until I flipped over one of the ASUS drives and saw it uses a cool 2.5 amps of 5-volt DC. Even USB 3.0 is only rated for 900 milliamps. So I tested the 5-volt rail of the hub and found that it was drooping all the way down to 4 volts before even my meter gave up and shut down. So that wasn't going to work with these kind of SATA adapters. That Pi option is starting to look a lot more appealing. I needed a solution for SATA data only, without power, and basically anytime you search for USB SATA adapters, they always come with power. Now, I know that these exist, but this is just a PCIe USB bridge to an M.2 SATA controller, and as a Linux user, I've learned not to trust 5-port SATA controllers. It doesn't matter anyway though, because one of my viewers, thanks again Helen Croft, came in clutch and found the perfect single-port data-only SATA to USB 3.0 adapter. I ordered 3 of those, and then had to wait. This was delay number 2 for this project. After getting the new SATA adapters in, another was DOA. Seriously, I can't make this up. I opted not to get a replacement this time though, because these have a new problem. They don't fit in the hub. Even shocked. I was buying another thing for this project though, and since one of these adapters was dead anyway, I figured I still have the USB powered ones, and one drive at a time, it did actually work with those. So I used a mix of adapters which let me fit everything I need. I also ended up making a custom adapter cable from Molex to USB-C and 5.5mm barrel jack to power the hub and the drive adapter. Which brings me to this. Bask in the glorious spaghetti mess to make all of this work. In that mess is also a USB serial adapter because I needed to replace the onboard one as well. It turned out that internally the robot had a DE9 serial port anyway, so that was very easy. That made me realize that the rear 50-pin Centronic sized as well, so I bet there are older models of this system out there with DE9 serial and SCSI drive connections instead. Anyway, at this point I was really wanting this project to be over, so I used the clamp on the hub I got, which is meant to go on the edge of a desk, and just squeezed it onto the serial port of the I'd now disconnected. Not my finest work, but I was trying to get this video done and tired of delaying it. I ran all of the cables I needed up into the drive cage and popped in all the ASUS drives. At this point, I took a moment to make a few simpler mods as well. The reject spindle just onto the metal top. I may use this for discs that I want to mark for deeper rip attempts later, but I don't want to scratch them, so I put some soft pads down around it. I also cut some of the pads to put on the doors because they mount fairly loosely and rattle a lot. This dampened them and made the unit much quieter. With that, it was all together now, and I could try the ASUS drives in it for the first time. I knew I would need to calibrate the robot though, because the drive trays would be in different positions, but I wasn't prepared for how difficult this would be. Actually, it's impossible, but figuring that out and solving it was a whole other problem, and it was the third and largest delay to this video. ASUS very clearly designed these drives specifically not to be usable in a robot like this. There are at least 3 different design choices they made that were all completely unnecessary, except to make these unusable for this. First though, I need to talk some more about the calibration features that this robot has. When it goes to place a disk on the tray, you'll notice it drops down in front, then slowly moves towards the drive again and releasing the disk. It does the same motion in reverse when removing a disk. The original software described this motion as the short tray setting and gave you some drop-down options for how to handle it. It's meant to account for drives that don't fully move the tray away from the drive bezel, where the disk might hit the bezel. The original software doesn't expose this calibration anywhere near as openly as it actually is. After reverse engineering more of the commands, I know you can calibrate the height it stops at over the tray for both loading and unloading separately, the distance that it slides across, and tangentially related, the exact vertical position of all 3 drive trays. The original software only lets you cut the top one and then just guesses for the other 2. Now, at first, I didn't think I would need all of these short tray settings, but it turns out that they are vital for these ASUS drives. I'm going to hide the first problem I found for now, but a problem that stemmed from it was needing to get the short tray working, because these drives don't eject the tray out far enough for the disk to be able to be pulled up. This means that we need the wiggle motion to get the disk in or out. But there's an extra fun problem related to this. The door on the tray is extremely close to the disk. It's actually so close that there isn't physically enough room for the disk to be removed while level. ASUS designed this drive so that the user must slightly angle the disk as they take it out. This was imperceptible before I put it in the robot, but once I started calibrating for these drives, it became painfully obvious. So the first thing I had to do was remove the drive doors. That's why they've been missing in this video, and I'm actually showing some spare drives that have them on still. But even that wasn't enough. After removing the door, you still can't move the disk in and out while level, because there is a lip in the seal for the tray door that sticks down. Now, I could have easily removed the drive bezels completely, but I didn't want a bunch of dust getting inside. So I dremeled off that top lip on all 3 drives. This allows the short tray motion to have the clearance to lower the disk in place. So now it works, right? Well, after I made those mods, I attempted to let it run through a set of test disks, and it was going great until... What just happened? Well, let's go back to the first problem I found. First, let's eject a disk from the drive like normal. Take note of the silver mark on the tray though, because if I now close the tray and just reopen it, the tray sticks out more than it did before. Let me say that again. The tray ejects from the drive different distances when it does or does not have a disk in it. The only reason I can think of to possibly do this is to make using it with robots like this impossible. Purely an antagonistic feature. And no, vertical orientations don't excuse this either, because it would have to short eject the tray when empty as well to be able to hold the disk in when loading like that. Now, the drive uses reading the disk as the detection mechanism for this. There is no sensor that we can fool to make it think there is always or never a disk in the drive. But as evil as that is, I was originally tolerant of this problem though. I carefully calibrated the robot to drop the disk just barely far enough in for the short tray position to work, but they would also sloppily drop slightly on top of an empty tray and fall into place when closing the door. After the first disks are loaded, when doing a bulk rip job, the tray position should always be the same, since the drives will always have a disk in them when they open. So the problem is solved, right? That brings us back to this. I don't know what happened here, but the drive ejected out the full distance despite there being a disk in there. The arm attempted to pick up the disk from the short tray position, but that's not where it was, and the system jammed. This made these drives unpredictable because there was no way to determine where the tray is to have the arm pick it up from a different spot. I was about ready to just scrap the whole thing after all of the other mods I had to do, amounting to nothing now. But I had one more idea of how I could solve it. But first, I needed to open the drives. I had noticed that when the drive trays are fully open, they hard stop. They are being physically limited, not with a sensor. But with a disk in the tray, they can still be manually pulled out just a little more. I wanted to see what this looked like inside, and with the case off, at least the full stop travel position was obvious. There are tabs on both sides of the tray that run into the case and positively stop it. So I opened another drive after it was ejected with a disk, being careful not to move the tray, and found that it stopped right before this opening next to one of the stops on one side. My best guess is that this blue switch under the tray that is actuated by the tray gearing is how it knows it's in this position. This is probably also the same switch that lets you push the tray back in to close the drive. Now, I think trying to defeat this switch and getting the tray to always fully extend is a fool's errand. But the only thing I really need is consistency. So going back to the positive stop, I wondered, could I make it stop without a disk in the tray in the same position that it stops with a disk? And the answer is yes. Once it hits a stop, even if it's shorter than normal, it works just fine. And I instantly knew what I wanted to do. That opening beside the drive tray stop, I wanted to design and 3D print a part to fit in there to extend the stop location inside the drive. It took 3 revisions to nail the exact stop position, but this ended up being absolutely perfect. I installed the stops in all 3 drives, and that finally made the drives usable with this setup. They now always open to the exact same position, and I can load and unload the disks cleanly. I have had to do so many mods and exceptions that I'm still expecting to have to iron out bugs on this thing, but it finally passed my rip test flawlessly and is working exactly as it should. So I might be in the clear. So now that it's fully working, let me walk you through how I can use this machine. Let's rip the soundtracks for Breath of the Wild and Tears of the Kingdom. 14 discs total. For my software, we set this up exactly the same as the RoboRacer by defining a controller and assigning drives to it. You also need to specify the order of the drives for the controller though. I also have some options for the groups and a FIFO that I'll set up for now, but talk about more when we get started. Now, to prep for ripping, I just need to load all of the discs. I'm going to reverse stack these, starting with Tears of the Kingdom's last disc, so we can go completely in chronological order. Now, I get the software up and running, it calibrates and initializes the robot, I add the hopper with the discs to the machine, and we're ready to go. Now, I do have a backend option for providing a single file with all of your media information at once, so you can predefine something like this. But I'm just going to manually add them through the web interface this time for visual reasons. All I have to do here is enter a name for the output folder and optionally a description. As I'm adding these, you can see the robot grab the discs for them and start ripping. And once I've typed in all of the basic info for the 14 discs, it's completely automated. And now we can see the groups and FIFO features in action. For any set of drives, my software can have them put into a group. And when you input your media sample info, you can either specify a specific drive to rip with or a group. When you use a group, it will find any available drive in that group to load the next sample into. This lets software track and manage the optimal use of the 3 drives as needed. But CDs don't all rip at the same speed or for the same amount of time. So disc 2 or 3 in a set could finish before disc 1. And if the robot removed those discs first, the order of the output stack would now be different from the order of the input stack. So there's the FIFO option, or first in, first out, which tells later samples to wait to eject until all previous samples have finished. This is important because it makes the manual process of recasing all of the discs after much easier, because it's the same order, just reversed. Lastly, if I've already started ripping and I want to add a new sample, I can just put it into the next bin counterclockwise. When it reaches the bottom of the first bin, it will remember that it is empty and move to the next bin to continue. So I can keep adding more samples and let it work without stopping. I'm also planning on adding an option to add the sample to the front of the list for robots that don't have multiple loading bins like this though. But with that, the Auto Publisher LS is now finally ready to be put into service as a disc ripping monster. As much as a pain in the butt it has been to get it working, really glad I did get this unit over any other arm changer. Using these ASUS drives in a robot like this that you cannot fully calibrate would be impossible. It's only thanks to the short tray features that I'm able to defeat ASUS. So, while it pains me to say this, after all of the trouble this thing caused me, I think this might be one of the best options for a bulk ripping robot. That makes it all the more surprising that no one else has tried to reverse engineer one of these. Now, I still think that the top loading models are probably the better option. As long as you get one that doesn't have the stupid drive tray, they're probably a lot easier to modify with a better drive. Well, that's going to be it for now. I've got a lot of disc ripping ahead of me now that I can queue up as many media samples as I want, let the robot do the job for me. If you enjoyed this video, you may want to subscribe because I know I'll talk more about CD ripping in the future. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. I'm always looking for Now that's it, and I will see you next time. As many media samples as I want, let the robot do the job for me. If you enjoyed this video, you may want to subscribe because I know I'll talk more about CD ripping in the future. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. Hello there.
If you can hear that bird outside, just deal with it because he's having a great time. This is a bit of a weird story. On October 6th, I won an auction for my digital Deck Rider 2. It took quite a bit of work to get it going for a few reasons, and the eventual video released on November 1st. But on November 4th, I realized I had an unread message from someone local who had offered me a Deck Rider 3 back in September. I didn't see it until they sent me another message right after I released the video on the 2. Now, the 2 and the 3 are very similar. They're practically the same, except for a few key differences. The 3 is RS-232 from the get-go, and supports 9600 baud, which both make it drastically easier to use. However, I didn't really need 2 of these things. But that's a problem for future Shelby. So I met up with Andrew, who graciously gave me the Deck Rider 3 and a few other curiosities that came from a business shuttering some old hardware. Now, I wasn't planning on making a video about the restoration of this Deck Rider 3. I thought I was going to do a quick stream where I reformed the caps, maybe replace a similar diode to the 2, and got it up and running. But oh boy, was I ever wrong. I'm looking at nearly 23 hours of footage of the restoration of this thing now, and it is absolutely a story worth telling. So this is how I spent nearly the last 2 months getting an extremely dead Deck Rider 3 back up and running. On November 9th, the first day I picked up the 3, I had a plan all in place to mess with my stream chat and act like this was the 2 that now just magically had a serial port. That didn't last long because they're pretty obviously different inside, it turns out. Now, I could have turned it on at this point because I was told by Andrew that he had tried to use it and turned it on before that, and it shows some signs of life. But I wanted to look it over first because I was pretty burnt by the 2. The first thing I noticed was that the print carriage was stuck again. I was able to get some movement out of the motor and idle pulley though, so once again, the carriage itself had seized.
Serial port that we want to use, again, is a little weird because you don't provide the entire path to the port. You actually have to provide it as a relative path to the dev device folder. That always trips me up when I'm trying to use this stuff. Now, as soon as I press enter here, this will immediately become a serial TTY. It's ready for me to log in. Oh my gosh, it's so cool! It's just ridiculous! Okay, so here's the thing. It totally works. So if I do an ls here, it's going to print all of the files that are in my home folder. I didn't know it was going to do double direction printing. Oh my gosh, this thing is awesome! This thing is ridiculously good. This is one of the best vintage terminal experiences I've had on a modern computer. Now, I didn't actually specify a particular terminal interface here, so let's just, for kicks, echo term and see how it set it up. So it set it up as a VT102, interesting. So I was wondering what terminal interface codes it should use. Since it is a deck, it would be similar to the VT100 series, I imagine. I don't know how similar it is, because I don't actually remember when that terminal came out, but it looks like it's close enough that this is going to work out well. All right, now we do have some problems here. Because this is a hard copy terminal, it means everything that we print is going to show up on the paper. And we can't use something that is a curses type application on here without it doing weird things. So just for kicks, I'm going to run Vim, but we're not actually going to be able to use it. Oh my gosh, it's so much worse than I thought it would be. So yeah, we can't use all of the Linux applications that are out there because it's gonna do really weird stuff. So let's just quit Vim, and there we have our terminal back. That wasted a whole sheet of paper, not unsurprising. All right, let's go ahead and line feed so we can get up to the next line. Oh my gosh, this is so good. Now I can do something like this. If I go cd git, all right,
I can CD RT 4K remote as an example here. This is, well, here, I can just show you. This is a repository I have been working on that is a remote web interface for the RetroTink 4K here. So we can run git log as an example. I offset it by, oh, that was worse than I thought it would be. Beep, beep. Oh, I didn't realize git log was interactive. Okay, so that's not good. We want to quit that. Man, everything is just using curses, isn't it? This is rough. Yeah, but if it hadn't been a curses application, that would have just worked normally, but apparently it was. Yeah, this is the whole problem. For kicks, we can just cat RT 4K remote, and we can print the entire file to the paper. Oh my gosh, why is it doing whole page breaks? Why? Stop it! Oh my gosh! This is the danger of doing this stuff. I mean, I can... It has its own internal buffer. I can't stop it. There we go. Yeah, it's hard to use Linux computers with this kind of thing because it's all the software is using more complicated protocols now. So I will revisit this, but it's going to take getting a very specific set of programs whitelisted that won't do horrible things like this, and probably trying to figure out how to make it work. It's possible that it running in VT102 mode is sending like a screen clear command. It's trying to redraw from the top or something. I don't know. So I might have to look into like a raw ASCII terminal interface, or maybe there is a dedicated hard copy one. I don't know, but that gives you an example of what using this as a Linux interface is like. Well, it's been DeckWriter 3 fully functional after just an absolutely insanely ludicrous amount of work. I genuinely cannot believe it took that much effort. That was ridiculous. But there it is, fully functional. I know better than to try and hunt down all of the Linux configuration stuff to try and make this thing work better right now for demonstration, because it is not well documented anymore. This is actually a thing that I just complain about all the time. Linux terminal entries and Linux terminal support is really bad nowadays. Most people hard code the terminal escape sequences. So what I'm really going to have to do here is use something like Screen to wrap the escape codes from the terminals to make it interpret them correctly to work with this thing. And it's going to be a whole trial and error situation to try and figure out what the best setup's going to be. So it's not going to be easy to make this possible. But it's still so insanely cool. I will be able to connect it to the data generals back there. You're probably wondering why I didn't do that yet. It's because the serial card in that is set up for 19,200 baud to print much faster to the Dasher terminal, which also supports that. I have to pull the card out and reconfigure wire jumpers on it to reduce the baud rate. And I will do that once I mod that terminal to also work, because I'm probably going to set it to be 300 baud on the data general. That way that one can work with it as well. I might even just use that one as a dedicated printer with that thing. So I have a little bit more work ahead of me with these. This one, we need to figure out what the Linux software is going to look like. That one needs a serial mod, and then I will connect them to the Micronova and get it printing through at least this, but hopefully the DeckWriter 2 as well. But that is all for today. Oh, I'm really glad to finally be closing the book on getting this thing working, because this has been like a 1.5 month long project. Absolutely insane how many things I discovered one after another, repairing one piece at a time. The most strong, ridiculously long project I've had in a long time for sure. So yeah, definitely glad to be putting that one behind me, but I'm so excited that it works. Well, if you enjoyed this video, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon, but for now, that's it. Now, let's see it print.
Hello there. I have a video today about something that I've been trying to get in one form or another for years now. I've clearly been after printing typewriters for a long time. I looked at the Smith Corona memory writer, the Brother EP20, the Xerox memory writer, and I also have an IBM Wheel Printer Series 2 that's sitting around here somewhere. They're all very cool, but none of them can do one of the other features that I've been after, acting as a serial printing terminal. But today, I finally managed to get my hands on one, and it's down. Is a digital deck writer 2 or an LA30. LA basically the same thing. Here are the two enormous spools of ribbon that are thankfully still here. Now this thing has definitely been used, but again, I don't think it's been used a lot or recently, especially not now that I'm seeing what those caps are doing. I'm really glad that those are in there because those are not universal typewriter 2-inch spools, so those are a little different. Now I'll get some tighter shots in here, but I want to remove this whole piece first because, like I said, it's only a few bolts. Actually, there are bolts missing that should be on there. Okay. So there are only 4 more left along the front here. I can see some standoffs that should be about here and on the sides. That's not a great sign, but let's get these off. Now, I have found, and some of them even came out while I was jiggling it around, a bunch of loose fasteners and things in here. It's a little concerning because, for one, I need to find all of those before we can power this thing up to make sure that nothing gets shorted. And 2, I don't know what they go to. Now, I don't know if the platen handle comes out easily. So what I'm going to do is I'm going to try and lift this over into the side. There we go. Oh, yeah. Oh, my gosh. Look at that incredible solenoid setup. Dude, that thing is ridiculous. So I assume these are each individual ahead, and I'm guessing it's only 7. Now, weirdly, I can't move this. I don't know if the stepper motor over here, like locks or something when it's not all. The belt looks like it's in really good shape though, which is nice. It even has a deck name and part number on it. That's hilarious. All right, now let's talk about a little bit of an elephant in the room with the keyboard. This is a stackable high-tech switch keyboard, which if you've seen my videos on the H86 are the bane of my existence. But so far, and over farther and splay out the tube, causing it to push a key. The that though, thankfully, we can see there's some weird higher than number 3 to press it down to make it go farther down into the stem, but they could just as likely crack it, so we're not going to mess with that. It's kind of a shame that these have that problem, because for being a linear switch, I really like how these feel. It's probably just because they're really heavy actuation force or something like that. But yeah, that's what this is. They're probably gonna work just fine. I don't think I've ever seen a stackable high-tech switch keyboard have an issue, so at least it's not foam and foil. We don't have to worry about that. It's just the second worst kind of keyboard, if you ask me. Now, I don't really need to remove the keyboard, but I think I should, just to be able to see more of what's underneath of here for the random loose parts that I keep inside, so it's
is gonna suck, but oh well, I think it could be done. Don't know the cable situation is for this. Is okay. Oh, these are okay. Weird. Why? That complicates things. All right. I don't think I want to move it too much. I just want to look underneath, make sure it looks out of place. Spider webs, but that's it. May 1976 stamp date. Move this around too much. These cables are very stiff. I don't want them to crack in the insulation or anything, so we're just going to put this back, I suppose. You know what? I'll leave it loose so I have some room to get my hands in places. Because there's some stuff like down in there I can't reach. All right, getting in here a little more, this is kind of interesting. There's no soft backs. That just lifts off? Is that, ooh, that is supposed to have plastic retention snaps. Okay. That explains why this has been missing on all of these that I've seen online, though. I'm going to set this aside, probably try and re-glue that snap on. There's nothing I can do about the other side. Anyway, the reason I was getting so tight up in here is this is the backstop, apparently, for the printing mechanism. It's just a aluminum bar. Usually this is like a soft piece or something here so that the pins don't, like, mushroom. That's weird, man. So I assume the impression strength here is going to be pretty critical to make sure that you don't just destroy your print head. Hopefully that hasn't happened to this one, because I see it says digital on there, so that's not going to be easy to replace. There's not too much to see up here, but there is this part. So this is a Litton brand stepper motor. That's kind of cool. But this is a single piece spindle gear for the belt, and I can see some cracking on there, likely from contraction of the plastic over time. I'm hoping that's not a problem. But again, I can't move this. So something somewhere is holding this in place. I don't know where. I'm hoping inside of this there's maybe like a peg or something that is locking it, or maybe the step strength of the magnets is just insanely high. I don't know, but I'm hoping it's not a problem somewhere. One other thing I would like to call out that is kind of a disappointment. This here is a speaker for the Bell character. It's not an actual bell. I mean, come on, how awesome would it have been if there was an actual bell in here? Okay, I can't stop calling things out because I mean, this thing is awesome, man. But this is something that I had noticed online. So every picture I've seen of one of these plates that I believe are just like polished steel or something, on most of these, those seem to be rusted like crazy. This being Arizona, so it's very dry to begin with. And the fact that this was probably kept in a warehouse for the last 40 years means that these are in fantastic shape. And that also gives in really good shape as well. So seeing those be so nice and shiny is one of the reasons that I bought this thing. Couple of other things over here. We have the motor for the platen control, and we have a lid close detection sensor too, which is a giant switch over there. Another thing here, this is the paper sprocket, and it's a regular belt that has plastic pieces that hold the paper in. I've seen some of these where it's like a flex PCB that has little knobs like connected to it somehow. This seems a lot more resilient, other than the fact that the rubber belt would decay and fail, but I really like that solution, so I'm optimistic about those.
All right, I think the last thing I have to show here is this sticker, which contains some serial number and configuration info, I believe, for this unit. I couldn't quite figure out how to decipher this, but I think there might be information in the manual on it. All right, well, it's kind of it for what I wanted to look at up here. I didn't think that this capacitor was going to take this long to reform. We are 20 minutes into it, and it's not even a quarter of the way done, and it only gets slower as it goes farther along. So I'm a little nervous that these caps aren't going to pass. But I'm going to let this go, and we'll see what happens. Yeah, this is... man, I may end up giving in and raising the maximum current level. We'll see. I don't know. I want to give it a little bit more time and see how it behaves, because this doesn't seem right. This is where this started to take a turn. I thought I could knock this out in 3 days. Well, everything you've seen so far was filmed over 3 weeks ago now. My concerns about the capacitors were warranted, and I ended up spending a week on just reforming them. Slowly. The Sanguamo caps were very degraded, and I think make for an interesting case study because they exhibited a behavior I had not observed before. I'm going to assume here that you've watched my video on how the capacitor reforming process chemically works, and if you comment on the video to debate it, I'm just going to reply to you with a clown emoji. Now, I described that ideal curve shape that I'm looking for, and some of the caps did do that. This is what I expect a healthy reformed cap to look like on the first pass, and rerunning the same process on the cap after should have a flat line as it no longer uses energy to reform the dielectric. But some of the caps got to a point where they started to go backwards, and the lower voltage means an increase in current draw. They always recovered and continued though. I observed this happening 3 times on 2 caps. My best guess is that a portion of the dielectric was weak, and as the voltage raised, it started to fail. And as it thinned, it started to consume more of the electrolytic fluid to rebuild it, which was a very slow process that also generates heat and pressure. I run my cap reforming with a low current, and it's possible that if I'd set this up more aggressively, that it could have caused a rupture. And without reforming, this almost certainly would have blown in the full circuit. This is the first time I have observed what I believe to be a capacitor being definitively recovered with reforming. Every capacitor I reform, I always run through the process twice to see how its performance changes, and they always improve. And even that can be helpful for second-order effects, like not overstressing a power supply by reforming in circuit rapidly. But I've never seen something as drastic as this that likely avoided a catastrophic failure. I mentioned it was specifically the Sanguamo caps, though, that were degraded. The huge 60-volt cap was made by Mallory, and it reformed probably 4 times faster than the Sanguamos did on its first pass, while also going to double the voltage. It's probably a goal or collect coins. For each of these, I mapped not only the start position, but also the end. This is because of the routing menu. This is a speedrun focused option, but it could still be used by anyone. Hello there. I am still on a bit of an Apple II kick, and especially as I continue to learn how to use the machine and get more comfortable with it, it's just such a good, simple computer. I'm really, really liking it. So when I had DJ Dowie from Overland Park, Kansas, reach out to send this package, I knew I had to keep the Apple II train going, because what they wanted to send was this, an A2 DVI. This is an Apple II HDMI video card. Today we're going to install it in that thing and check it out. So this is it. We have the slot for the Apple II, a Raspberry Pi Pico, it supports the original or the 2, an HDMI port, a handful of parts there, and that's all you need, and you get HDMI out on an Apple II. So when I was first offered this by DJ Dowie, I was like, that's a thing, and
I guess that's partly because these are very new. We'll take a look in just a moment at some of the open source repositories involved with this thing. But yes, this appears to still be in development as of last week. Matter of fact, I just updated the firmware on this thing right before we started recording this video today. And this is really, really cool. Now, I'm excited about this because I like being able to do video of all of my computers. In the last video I did with the Cosm Soft Strip, I was actually using 3 cameras